Good evening. My name is Mike Cadwell. I'm the interim director here at the Knowlton School of Architecture, and it is my great pleasure to introduce tonight's lecturer, Stephen Kieran, founding partner of the firm Kieran Timberlake. The theme of this autumn Baumer Lecture Series is precision, featuring practices that are both conceptually consistent and rigorously executed. Kieran Timberlake epitomizes such a practice, as their handsome new book, available outside in the gallery after this lecture, testifies. Kieran Timberlake interrogates construction as a mode of inquiry in an attempt to find new possibilities. To quote the partners, "From the beginning, our practice has been based on craft and in construction and the careful integration of the two. Over the past decade, we'd become disappointed with the level of quality of the craft as executed, not only our own, but in architecture at large. We advocate the return of authority and responsibility for design and control to the architect, as it once was, in the role of the master controller. We don't think we will be master builders again in the sense of Brunelleschi 500 years ago. But by embracing integration, collective intelligence, and the technological tools available to us, architecture can regain the kind of control of processes that they have not had for nearly a century." The firm has received over 100 design citations, including the 2008 AIA Architecture Firm Award and the 2010 Cooper Hewitt National Design Award. It is currently involved in a whole range of projects, the U.S. Embassy in London, as well as projects at Yale University, the Sidwell Friends School, and UCLA. In addition to his architectural practice, Stephen Kieran teaches a graduate design studio at the University of Pennsylvania and has also taught at Princeton University and held endowed chairs at Washington University, Yale University, and the University of Michigan. He lectures extensively in the United States and abroad, and we are pleased to welcome here this evening to the Knowlton School of Architecture. Stephen.
Thank you very much, Mike. Can you hear me in the back, or should I adjust that microphone up? A little bit up? How's that? Is that any better? Okay, good. Thank you very much for that introduction. It's wonderful to be here. I think this is our firm's first visit to Ohio State. I'm not quite sure about it, but I know I have not been here. So it's a delight to be able to share some of our practice with you and the way we go about practice. And I want to begin with a little bit of a provocation for you that is what we are thinking about as the underlying ethic of our work at this time. And we certainly, like all of you in the room, live to make beautiful form. That's the first obligation of the architect, is to make buildings of desire on the part of our clients and those who encounter them. But increasingly today, we find that we are operating under a new mandate, and it literally is a mandate. It's one we experience daily in the course of our existence as architects. It's one our clients actually place upon us and thrust upon us, whether we want to do it or not. In our case, we openly embrace it. Many are drawn kicking and screaming to the table on it, but it's quite simply this, that there are really two huge underlying problems in our profession today: productivity and the environment. James and I believe that they are intimately related problems and can be better solved when fused together than they can be singly. You'll see in just a moment some of the underlying reasons why these are so important. But they have thrust upon us a demand for performance that goes beyond the artistic quality and appeal of our form making. And That is a reality that we are being held to today, is how we're going to improve the quality and scope of what we do in less time and for less money, and enhance the environmental and ethical performance of our buildings in terms of their management of energy and resources. To get to this mandate, we've had to restructure our firm over the last decade plus around a whole realm of inquiry, because you can't get to performance without articulating really precise and important and difficult questions that need to be answered in order to inform your design, so at the end of the day it can actually perform. The underlying problem and reasons why that mandate exists are available to all of us in this startling diagram that I continue to be depressed by when I see it. But quite simply put, let me see if I can get over to it. This blue line across the top represents the productivity of the economy at large, including the construction industry. And since the early 1960s, that has gone up 220%, roughly speaking. It's a lot. At the same time, we in the construction industry and the design professions, architectural and engineering and other design professions are part of it, have actually declined by a good 20%. And that's a pretty remarkable and depressing swing. And our clients have really been telling us for a number of years, we're not going to put up with it. We're not going forward this way. And it's frankly been responsible for the decline in the quality and the craft of our buildings, because they have gotten so expensive and delivered so little that the budgets erode, and we wind up with craftless and soulless buildings almost by default because of our decision as a profession, in essence, to really not address this. And then secondly, at the same time, we're confronting an extraordinary revolution, literally, in the importance of the environment. And you can see that buildings, again, which are a huge part of the energy use of our nation and of the world at large, are again climbing in their energy use at a steeper rate than transportation and industry are. Industry's almost flattened. We're continuing to climb. Another huge challenge that, again, whether we want it or not, it's thrust upon us. There are mandates out there that government and clients are placing on us. If we don't want to meet them, we have no choice. We literally have to. So the structure of our firm really stopped being focused on planning and doing things solely, but started looking at how to monitor and learn from what we had done so we could improve upon the past and enhance our productivity and our environmental performance. So the bottom half of that circle, monitoring and learning, I'm sorry to say, is almost altogether absent from architectural education, and it's certainly absent entirely from practice. We don't rigorously monitor the performance of what we've done. We don't go back to what we've done with that data and ask questions about the performance and learn from it so that we can improve the next time around. It's as though every building the same old thing, while the world we're trying to build in gets more complex and our productivity declines and our environmental performance declines. So the structure of our firm has at its core what we call a research kernel. It's a group of staff. There are now 7, and we have an 8th that's being added as I speak, who support everybody in the firm and drive the practice of the firm. Some are architects with a research bias. Others are environmental scientists. Others are mechanical engineers. There's a variety of skills that they bring to the table that aren't necessarily the skills that we have. But that's what sits at the center of our practice. We research across 4 realms: processes, systems, the environment, and materials science. And oftentimes, research questions are generated by our projects, and they're formalized and tended to as real research questions as a scientist would take them on, with outcomes that are shared with not just those in our office, but our clients and with the profession at large. Sometimes those will spin off into product designs, so we find ourselves increasingly moving into the realm of product designs, including software designs and building products are all things that we have underway as part of our practice at this time. Early on, when we first started the research group, one of the first tasks James and I undertook to address the productivity question and the environmental question was look at other industries that made complex things. So we toured the world, literally, and crisscrossed the U.S. The only place we went here in Ohio, I think, was Toledo to a Jeep assembly plant there. But we looked at how the aircraft shipbuilding and automotive industries were making the very complex products and large products in some cases, at least shipbuilding and aircraft make large products as well, to see how they were doing it. And that became part of and parcel of ultimately our book, Refabricating Architecture, which still drives our firm's approach to the questions of productivity and the environment. And simply put, when we went around and toured all these industries, this is what we found their new paradigm was, that they were providing more quality and scope in their products out of all proportion to the cost and time required to produce them. And they were starting to do so in an environmentally ethical way that accounted for materials and energy use and enhanced them. And that was the paradigm that the major corporations that build these large products were operating under, but it was not the paradigm we in our industry are operating under. So that for us, the gist of it is that is a new paradigm, and we have to add to this, of course, the obligation I began with, which is form. It's still got to be artistically extraordinary and beautiful and compelling and become an architecture of desire in the end. So I'm going to share with you several projects in the time we have together this evening to show you how we use this realm of inquiry to form our projects. And it is our firm belief that the more we engage in and exercise and accept these constraints, the more they help us edit our buildings, make them more formally potent and simple and beautiful and elegant. So we in no way believe that these performative constraints in any way do anything except help us make more elementally beautiful, beautiful architecture. So after Hurricane Katrina, we were given the opportunity to build what's now called the Special Number 9 House for Brad Pitt's Make It Right Foundation. And we undertook an approach here that was different than the rest of the architects that have been participating in this, and it had to do with jobs as well. Part of the objective was to look at the productivity problem, utilize some of what we had come to learn about off-site construction strategies, and try and develop a system of parts here, a mass customizable system of parts that could be built in New Orleans, providing jobs that after the city is rebuilt could be an export industry for the city. So we looked at common components. We looked at variable components as part of our mass customization strategy. There are two different roof strategies here. And then there are a series of interchangeable cartridges here off of these common elements that are common to every house that an individual homeowner could select. So this was a system to design a house from a collection of parts with some capacity for both standardization of the carriage, but also mass customization of the outcome on the part of an individual homeowner. Make It Right has been relentless in their monitoring of their performance and learning from it. And They, in the course of about 3 years now, have driven the price of their first homes, which were roughly $220 to $230 a square foot, down to about $120 to $130 a square foot. They rigorously investigate building systems. There's quite a lot of off-site assembly in this that they've evolved into, and they're getting better because they monitor and learn as a client. At the same time that they are improving their productivity, doing more for less, their houses perform. This dwelling was designed with original simulated costs for a house of comparable sizes in New Orleans of about $1,670 worth of energy per year for all these systems. The actual monitored performance is $1,000 less than that. That's real money in the pocket of a homeowner who doesn't have much. It's a homeowner who actually generates more electricity than she uses, so she's selling electricity as part of her income. A real positive environmental and productivity outcome for our profession. It's becoming a community. It's now the largest community of LEED Platinum homes in the U.S. is the Make It Right Foundation's work in the lower 9th Ward. And the outcome, we believe, are houses of real desire. These people really love these houses. They love being in them. They love the quality of the light in them. The owner of this particular dwelling, one of the things she said to us when it opened was, I used to watch TV all the time. I hardly ever turn it on again. There's so much light in this house. I just want to go outside. A second exercise that I want to share with you this evening is the cellophane house that we developed for the Museum of Modern Art's exhibit called, it was an exhibit in 2008 that they actually put up in a lot next to the museum in New York. But it was basically about prefabricated dwelling and off-site fabricated dwelling. It's called Home Delivery. This is a view of the building of Cellophane House on opening night with Saarinen CBS building in the background. And part of what we set out to do here was undertake an answer to that question on my original slide about management of carbon in the building. And very, very complex building with lots of initiatives, but I'm going to just focus on this one particular initiative here with you this evening. We don't know as architects how much carbon are in our buildings. We just don't count them. Buckminster Fuller used to always marvel at the fact that we didn't know how much our building weighs. It's far more marvelous that we don't know how much carbon is in them. And we don't, as a profession, again, ethically assume the responsibility for managing carbon because we don't even have a clue about how much we're designing with when we're designing. So we're designing a lot of products and methods to manage that. And it's critically important for this simple reason. We can focus all we want on operational energy that goes into our building, but when we put a building up, in the case of the two houses I just showed you, there's enough embodied energy already in those houses to equal 40 years worth of operational energy. So we're basically leaving a huge portion of the total energy on the table, literally. And it's frankly unethical for our profession to go forward thinking we cannot understand what we're doing when we're designing a building in terms of carbon in the materials we're using. So this is a dwelling that had to go up in just a couple of weeks. So it has three components to it, a stair, and these are more modular. It has an internal floor plate in the center of the building, and it has the front wall of the house. And these are the pieces and how they stack from the bottom to the top. And this is the fundamental architecture of the building. It's this joint, very, very elegant joint that was developed to be quick coupled together to enable this fast couple of week-long design, or rather construction process, and it had to be uncoupled equally swiftly. So here it is being put together in a plant in Lebanon, New Jersey, Coleman Industries, Coleman Building Corp. And here it is going up. This, what you see here was a week's worth of work, and we had a little more than 2 to finish off the entire dwelling. So it was all basically craned into position. It similarly had to come down in a similarly swift time at the end of the day. So on the left, you can see the house being disassembled, the joints that stack together and join, unstack, and allow the dwelling to be taken apart. And those modules were laid on the ground, then disassembled. Every single part is labeled with a code on it, and they were stacked into trucks and taken away. So it was designed for disassembly. Now, why is this important? In the left column on the bottom, you can see the total embodied energy closing on a million kilowatt hours of embodied energy. And this system allows us almost 100% recovery of the materials. So, in Philadelphia, I regularly watch brick row houses being pulverized in North Philadelphia and taken down to the ground. And the material is literally, pulp, masonry pulp at the end of the day. We believe in our practice that it's an ethical responsibility to start to look at the life cycle of a building and design for the long-term management of the energy that went into the building so we don't have to pulverize it. Recycling only reclaims a small portion of our buildings. Designing them for disassembly can reclaim more. The products can be used in other industries. The scaffolding on Cellophane House, we've sold some of the extra scaffolding to industry that uses it for machine works and machine enclosures. So, on the operating energy side of the equation, the test in this house was how can we get a high-performance dwelling from an energy perspective with really thin plastic skins. And this is some of our testing of the performance of the building during a pretty hot summer in New York City. We haven't tested it through the winter yet. That's more challenging. But the system basically manages and traps airs in between the layers of the skin, vents it out if we don't want it, vents it into the interior if we do want it. It's got integrated shading films that let in the type of light we do want and keep out the radiant wavelengths that we don't want. It has integrated photovoltaics on the skin of it to generate the energy to use the building. And it's part of an ongoing exploration in our firm of a wall cladding product we call Smart Wrap that began in 2003 in a Cooper Hewitt design exhibition. And again, the outcome of these constraints is beauty, we think, and objects that glow, places that people want to go into. When they came onto the site at the museum, this was the object people gravitated toward. So these constraints don't restrain us. They actually provoke us forward in terms of the desire and the beauty of the buildings. It comes out of the constraints. The more constraints we have, the better. The more we have to work against, the more artful our buildings are going to be. Shifting gears from houses, and by the way, on the houses, we pretty much only do houses when we can make entire experiments out of them in terms of how we change and address these productivity and environmental problems. So the larger buildings are more focused in that regard and more trying, but we are working in institutional building contexts to try and use some of the same principles as well. I'm going to share 3 buildings with you that have just been completed, so they're not published. They're not in the book that Mike held up this evening because they've just been finished this fall. The first is a new physics building at Rice. For those of you that know the campus, it's a pretty extraordinary Ralph Adams Cram designed campus. And the core of the campus, the main axis, is here with a lot of the Cram buildings, the old architecture school lining that edge. And the site for this building is in the engineering quadrangle. sits squarely in the middle of that quadrangle amongst a series of largely 1960s era, but somewhat earlier era buildings, and a couple of postmodern buildings like this one in here. So very much hemmed in within a tight historic context. They originally thought they wanted to move the building out to another sector of the campus, the way most research labs are moved today, but we were able to convince them to stay in the core on the building. And the plan is quite simple. It's a double bar building. There's a bar of laboratory spaces here and a bar of office spaces above this landscape here. So the ground plane out here is open with a building above. And there's a passageway through the middle this way and another passageway bifurcating the building here. It sits, we think, real well within the aesthetic context of the campus, but it's fundamentally performative at the same time. We do lots and lots of work over the specifics of orientation down to horizontally rotated and vertically rotated building volumes to completely understand before we start designing the environmental performance of a building, how much energy is falling on it. We model them across time throughout the year to understand that, look at the totalities of it, and then start to engage in designs that are, for which that is part of the generating form and of the building, is that ultimate performance. And then as we start to get into forms, we test them back against some of our earlier studies to understand the details of performance and tweak and tune them at the design stages, not after they're designed. We do the same for wind. Very hot, muggy climate. Hardly anybody uses outdoor spaces. Part of the effort here was to develop a building that used wind slipes to manage wind through the building and develop habitable outdoor spaces. So there was a detailed, very expansive survey of the site, including some wind modeling testing, some physical modeling on the site, as well as computer modeling. And again, all the design ideas were tested against those models for performance. And the outcome includes this shaded undercover area along the front flank of the building with the office wing above it, and with an open light well in the middle that provides ample and abundant daylight for all the offices in the building that face out into this well. And the well is a device that shades direct solar penetration into these spaces and allows for that degree of daylight to penetrate into the core of this very large building. Use of a water feature to help provide some cooling in the outdoor space here. And all of it very much consistent with the context in which it occurs. You can see some of these engineering buildings in the background from the 60s. This building sits well within the campus. The main entry and stair is located on the cross passage of the building. And again, this passage is sited for wind penetration through an adjoining courtyard complex. So very much part of our design thinking on it throughout is constant testing of the building. So basically the idea was to take the laboratory wing that did not want nor could it use much daylight and was a much larger volume, place it to the south so it screened direct solar penetration and allowed mostly penetration of light into this interior courtyard. And then on the north flank, we were able to open all the offices of the building up. So it's just good, sensible design based on a knowledge of the actual micro-performance of a site so that we don't create problems that require us to use extra energy to resolve the problems through machinery. Really, really simple, fundamental underlying set of premises, very, very difficult to actually put into play, though. So here's the south flank of the building with all the physics labs behind it. This building is at a LEED Gold level of performance. Pretty remarkable for a building that cannot have natural ventilation in it. So this is the screen that more or less sets up the whole promenade and procession from the core of the campus out to the building here. And you penetrate through into the interior, and this is where we've been able to really introduce the daylighting in these spaces rung by offices with classrooms and seminar rooms and meeting spaces in the connecting links in between these two wings, and a view of the complex as a whole with the classroom wing here, also lined with classrooms on the north facade of the main laboratory block here. At the same time, organizationally, we always ask social questions and have social inquiries about how the building might best be programmed to bring people together and engender collaboration. And in this case, it came together with environmental concerns, as it always should. All of the laboratories are over here across the top flank of the building, and they are able to be entirely flexible, which I'll show you in a moment, because they have similar mechanical requirements. So this is a completely different building in a way, with different mechanical systems designed for long-term flexibility of laboratory use. Similarly, this is an office block over here, designed with different mechanical needs altogether, different environmental needs altogether, and also designed for complete flexibility over time. And they're interlocked by these common spaces, these collaborative spaces in the middle that draw people from both sides, from the office and labs out into these collaborative spaces. So this is pretty typical of what the labs in the building look like, and they're changing daily. So it was an armature and an infrastructure to allow change. Physicists build all the time. They're rebuilding their environments every day. So that module allows them to do whatever they need and want to do in it. The offices will change less regularly, but they can easily be combined into suites. And so this building is designed for long-term flexibility that minimizes new construction, new materials, new embodied energy in the building, and optimizes the capacity of those that use the building to make environments that they need to be productive. And then lastly, these are some of the spaces in the center of the building that are these collective, connecting and collaborative spaces. Again, it's a whole set of constraints that if you go to work on them and listen to them and don't fight them but accept them, really in the end helps us edit and make our buildings more elemental and simple and direct. And out of that, we think, you've got a much better chance of deriving something that's beautiful because it's elemental. The biggest problem, by the way, I find with my students at Penn, I don't know if it's true here, is editing. Everybody, the fear is always making something simple. When there's so much complexity inherent in the details of a building, it's never something to be feared. It's something to be embraced. But it's just really difficult. It takes a long, long time as an architect to understand the importance of editing and using constraints to edit. We consider cost a very potent and wonderful editing constraint that saved us from doing innumerable bad details and bad designs over the years. So this building is a tiny little project, only about an $8.5 million conversion of a gym into a Quaker meeting and arts center at Sidwell Friends School in Washington, D.C. It's a Quaker prep school where the Obama kids are enrolled now. Long been a favorite of Washington Democrats. The buildings on this campus were frankly terrible. You can see this particular building on the right. This is a 1955 era gymnasium. It just sat squarely right in the middle of the campus here, blocking connectivity between buildings and connections between buildings and establishing no dialogue whatsoever between outdoor space and other buildings. In short, it wasn't doing anything to contribute to the making of a campus. So, as always, we look very hard at how to reuse existing buildings. About half of our practice is still in and about existing buildings, and about half is entirely new buildings. And James and I intend to keep it that way, whereas a lot of so-called environmental architects, like a Nicholas Grimshaw, for instance, won't go near an existing building. So we make it a practice to provide new life for existing buildings because it's frankly ethical. There's a huge amount of energy in those buildings, and we do everything possible not to demolish them, but to give them new life. And this was a building that the school was seriously considering taking down. So the interventions we had were few. We got to make a new portico and garden at the front of the building here. We got to add a new circulation route and stair along this flank of the building to the south. And we got to add a tiny little space here to the east in order to make enough room for not just the Quaker meeting in the old gym, but 2 performance rooms, a vocal and an instrumental performance room. So it's a modest but completely transformative project. I'm going to first deal with the urban design of it. This small portico out front, for once, starts to give this building an address to the principal outdoor space on the campus, the principal gathering space called Lubar Court. It shields a little tiny pocket court that is a garden here from that outdoor space. This garden becomes a little moment of calm before you enter the Quaker meeting. I live in Philadelphia. Most Quaker meetings have gardens that you enter through before you go into the meeting, intended to put you in the right frame of mind to experience the meeting itself, and that's what that little garden does. There is a circulation path then that's carved right alongside the old gym. This is the old gym through this door, but you're looking into the new meeting hall, which I'll come back to in a moment. And this passage cuts right through, and all we did was infill a tiny little space here in between another building and the gym with a new stair and a new passageway beyond the stair that allows for connection from the upper court here through and into all the spaces in the new building, down to the lower level and through to the campus to the new middle school that we built 4 or 5 years ago for them, and then down to their new underground gymnasium and out to 37th Street on the back. Very simple, insightful insertion in the building that profoundly transforms the whole sense of the campus, the address of the campus, the connectivity between buildings, and the conversation or dialogue between buildings. And it's a beautiful moment in a campus that doesn't have a lot of beauty to it. We've been trying to add beauty to over a period of years. You can see that little linear lamination of an addition here, culminating in a big bay window, projecting out above the lower level of the addition here. And it's a simple but dramatic transformation of the way the building's perceived and the way everybody moves about that campus and their sense of actually having a campus for the first time. All as a byproduct to the fundamental program, which was to transform this gym into a new Quaker meeting. And that was a tall order, again, that there was tremendous skepticism about. And we were guided by a really simple elemental diagram from the outset. The essence of a Quaker meeting is just silence and light. That's it. Just shut up, sit in a chair, and think. And if you really have something to say, get up and say it. If you don't, just sit and think and listen. It's fundamentally, architecturally, about these 2 things, about silence and light. To establish the silence and light, we developed a thick wall as a threshold in between them that contains all the systems of the building, so they can be real low velocity systems and not create any sound. There's a layer of structure that wraps around that and a layer of circulation that you can see here. In this diagram, by the way, right now, you're looking from here out this way, through the threshold and structure, through the circulation here, out beyond that circulation to the little garden that you walk through in the outset, and then to the main plaza of the campus beyond. So that was just a simple diagram. We thought about it at the start of the project, and that's what we did. And this is the outcome. It's a really simple room that focuses light in the center of the meeting. The meetings today are designed in central plan form typically, but there is no one at the center. There is an elder of sorts, in this case the headmaster of the school right there. But the idea was simple. Basically layer up the volume of the building with some new planes that you can see rotating about the center of the space to establish this opening at the center that provides a mysterious sense of light down into the core of the meeting and becomes the focus. It's everybody's focus in the room. Really, really simple, elemental thing. We screened out the old clear story walls of the building, but allowed light through them. This is daylight coming through onto the wood wall below, and allowed them to open at the corner to get slivers of daylight and view into the building. And the entire roof of it is clad with photovoltaics. This is a LEED platinum building for $8.5 million that generates huge amounts of energy and uses very little. So we made use of light in two fundamental ways. The outer layer of the building is generating energy, and the inner layer of the building just below that photovoltaic roof is architecturally organizing the daylight to provide the setting that allows light to penetrate right down into the core of the building. Just simple, elemental stuff. The third of these projects I want to share with you is a design that adds to and renovates Eero Saarinen's 1960 Morrison Styles colleges at Yale. They're buildings that needed a lot of love. Under budgeted at the time. Caesar Pelli was the project architect for it. He said the budget was $16 a foot, which even in 1960 was not much. But it was a very hard building without a lot of accommodation to it. So, you know, the basic idea here that came about with the addition and the renewal and renovation of it was to fuse the exterior of the building, which was its strong suit, its courtyards, through into the interiors and develop a kind of compelling sequence from the existing court through the existing building right down into the addition below grade. And the program called for a relatively large 30,000 square foot addition below grade here out in what is called the Crescent Courtyard, this beautiful crescent-shaped court facing the university's gymnasium. And our work is highlighted by this dashed line here. And we added a lot of new construction below grade for 2 stories going down below grade. A massive, almost lava-like pouring through the building and underneath the building of concrete out into this courtyard. And we used light wells. Most of the Yale buildings have wells around their moats, around their edges. And we use that contextual motif to allow light to penetrate down into the addition below. So very simple idea that begins in the courtyard here. We rebuilt and redesigned the courtyard to flatten it out so it could be used for play. Added a new water feature. All of the water is collected that falls on the site and used in this feature. Added a dining terrace and deck here outside the dining hall to extend the dining hall to the outside. These few things have made this actually the college that everybody's trying to transfer into at Yale now, as opposed to the one that used to draw students when they would arrive on campus weeping to their parents about what they'd gotten into. So it's this kind of a transformation of it, bringing things from the inside out and starting to introduce indoor and outdoor connections that didn't exist and don't exist elsewhere at Yale. That's really been transformative. But you come down through that courtyard, pass through into a lobby, and on one side is the dining hall. On the other side is the commons, which in Saarinen's original design was thought of as a basement rathskeller, and we've converted it through new skylights here into a light-filled common room. And you then pass through the lobby in between those two rooms, cascade down this stair that you can kind of see up here, cascade down this stair into the new addition below, which you can see beyond. And that addition is centered around a courtyard. So there are two courtyards here. This is Stiles College, this is Morse College. This is the Morse Court, this is the Stiles Court. This is the dining terrace and water feature that I just showed you in Stiles. Morse has a similar one. You've come through the dining halls here, the common rooms here, and then you go down this stair, and you're looking now at the perimeter of a sunken light well, a subterranean kind of grotto in this portion of the building, with all the spaces arrayed about it. The planning idea here was simple. Saarinen made every room in Morse and Stiles irregular, and all the passages are regular. One of the things we heard was about the lack of usability in portions of those rooms, so we did the opposite. We made all the rooms regular and rectilinear, and all the passages are irregular. Even the ceilings in the passages slope. It's all board-formed concrete of the same tonality as the original building. So here you're looking at this light well at the bottom here that organizes all the spaces around the perimeter. Another view on the other side looking up the stair into Morse College about this light well. And a view out into the courtyard. We had to literally build a building underneath the building to make that happen. So these giant blocks of concrete that appear to be sculptural are also part of the underpinning for the new addition. And we simply organized and formed them and developed patches and joints between new materials and old materials to basically make this and render this fusion of new and old artful. But literally, the way to think about this is it's an addition underneath a building, literally. We've sought a way to bring daylight into the buildings in ways that's memorable and that people respond to and never forget. We've looked at and worked on the articulation of these board-formed concrete walls that you can see here, these battered walls, I'm sorry. And the dialogue between those walls and the infill of a steel structural system for the decking of the building, we think is a pretty remarkable and rich dialogue of those two materials and conversations between them. This is literally a hole through the addition. It's a pit through the addition that has a huge tree in it above. It's difficult to grow large trees on additions. So we basically brought the earth right through the building. So we could found a tree that could get huge and take itself down to the ground. But you can almost feel the roots of the tree literally just projecting themselves through the mass of the building and finding solid earth below. And then lastly, I'm going to end with two projects. The last three buildings I've shown you are things, as I said, that we just finished this fall. The physics building at Rice was just published in architecture, and the Morse and Stiles project will be in record in November. These are two projects that are underway now, just finished, and we've just finished design documents and bidding on this. But the fundamental question here was the transformation of a sunken plaza that never worked for the city into a 21st century transit hub and a functioning urban plaza above it. And it's right at the base of City Hall in Philadelphia. This is City Hall, and you can see our new plaza design here. We're working with Olin as landscape architects on this project. Enormously complex moment in our city. The two main east-west and north-south subway lines cross above and below each other here. The subway surface lines, the trolley lines throughout Philadelphia come together with those two lines over here. The regional rail service for the whole region is right here and connects across. And there's literally hundreds of years of old buildings and foundations under it. But this is fundamentally the area that we're charged with bringing back up to grade again, making it a functioning part of the city as opposed to a sunken plaza, and then turn that area into a new transit hub at this intersection of the city. The plan is very simple. There's greenery around the perimeter to separate it a little bit, since traffic wraps all the way around City Hall, which is right at the main crossing of our two major streets in Philadelphia. In the center, there is a scrim-type water fountain that can be shut off and just used as plaza places and meeting places. Right now, this is the site of our of Philadelphia's demonstration that's going on in our city right now, with people camping in that sunken plaza. In the future, they'll be able to camp on grade here. There's a lawn platform here and a cafe over there. Very simple design, along with two entrances down to the transit hub below. And I'm going to come back to these two glass pavilions in a moment. Huge number of programming opportunities come to the fore on this plaza. Most of the day during the year that's not winter, it'll be a scrim fountain that people can play in it. In the winter, it'll be an ice skating rink. The lawn panel can be used for films. And there's also an artist, Janet Eckelman, who's developed an art installation, permanent art installation for this scrim panel as well. And very simply, the major part of our role was the transit hub and the entries to it. And what we sought out here was a really simple, elegant gesture. It's just a curved arc, two glass planes, really one portion of a continuous arc that penetrate from above ground down into the new transit hub below. It is formally fused to City Hall. The top of the west elevation is the center of the arc of these two plazas. And in a way, one way to think about the monumentality of this building is that this is the support for the monumentality of the building. And we can never compete with the masonry of this building. This is the largest piece of entirely masonry construction in the world. But we can compete with it in this way. This is the masonry structure of City Hall. And it was simply developing a glass system of these two glass arcs that has nothing in it but glue and glass. That's it. So it's a bearing wall and bearing glass roof system, and it's one of the largest ever attempted in the world on this scale. So, but it's a lot like City Hall. It's extreme. One is the largest masonry building. This is a real tour de force of very elemental glass engineering. And you can see the result here. We think it sets up and enhances the monumentality of Philadelphia and of City Hall, when everyone thought that they were going to have the opposite outcome of that. And then lastly, a few images on some design work that we're undertaking now for the new United States Embassy in London. It was a competition we won about a year and a half ago, and we're in design development on it now. But we had a lot of questions for this, but just the one I'm going to share with you tonight is the transformation of an American embassy as they have come to be known in the early part of this century into what we think of as a beacon for both diplomacy and for the environment, for our energy futures. And that is not what we have come to think of as our embassies. They have typically, since some of the attacks on our embassies in Africa, now more than about 20 years ago, our embassies have been hardened. They're basically concrete bunkers. So our objective was to basically invert the entire way that an embassy is designed, to make it a transparent, prismatic beacon that you can read any way you want. But we thought that that would be a more compelling image of what we might aspire to, as opposed to the bunkers out there. but at the same time, an environmentally responsive building. The site is just off the Thames, on the south side of the Thames, between Vauxhall and Battersea. It's about 5 acres, with the embassy sitting in the middle of its grounds here. It is really, again, a really simple idea. And the other 3 competitors had significantly more complex ideas. And we think this resonated because of the simplicity. It's a cube. All of the proportions in it are based on the golden section. It is developed with a performative scrim, a second wall. You can see the structure coming up from the site here and the building systems, and the inner building envelope, which is a blast-resistive glazing system, and the outer envelope that is a performative system that screens unwanted sun from the interior, reflects daylit wavelengths that we do want into the interior, cuts down on glare, and generates energy for the building. All facades of the building, the roof and the walls, have this performative scrim on it. It generates about 350,000 kilowatt hours of energy per year. The objective of this building that we set forth in the competition, and that we're still to this day working toward and trying to realize, is basically carbon neutrality, that we would ultimately, through a series of efforts, beginning with a high-performance building envelope in the first place, and with energy production, enough renewable energy production that we could actually sell it to the heating grid in London, as well as to the electrical grid, would allow us to go below carbon neutrality and get to true carbon neutrality, and actually pay over time for all of the embodied energy in the building as well. And then just 3 images from the competition scheme. This is a walk up the passage toward the entry to the consular section of the embassy, and it gives you a sense of the detail of how this prismatic form is created using stress skin ETFE envelopes with fritting, solar shading films, and photovoltaics integrated into them to really enhance the performance of the building envelope. This is the view from 9 Elms Lane along the bank of the River Thames. And it's transformative in terms of new embassy making in the US. Instead of seeing a hardened bunker at the base of it, you see into the interior of it. Instead of seeing portholes for windows, the entire building is this transformative, transparent cube. And it sits well in London, in between Battersea Power Station here and the Covent Garden Flower Market here, along the river, as what we would hope would become a transformative beacon of our democracy and our presence in the UK, that speaks in symbolic terms in ways we would like to be spoken of and like to be thought of, but also at the same time becomes a responsible energy citizen of the world, and moves us into a position of leadership in a field of environmental design where we have been the international laggard in many regards. So that's it.